Hello guys, in this video we are going to see about knuckle joint, how to create a CAD model for a knuckle joint. So before getting into the CAD work, we'll see a basic brief about the knuckle joint. A knuckle joint is a mechanical component used to connect two rods or links that are used under tensile load and must allow a small degree of angular motion or rotative relative to each other. It is commonly used in applications such as linkages in machineries, structural members, and automotive systems. The main components of knuckle joint is eye, fork, knuckle pin, collar, and taper pin. The features of knuckle joints are as follows: angular movement, easy assemble and disassemble, using under maximum tensile load. Common applications of knuckle joints are tie rods in steering mechanisms, linkages in suspension systems, structural linkages in cranes and bridges. Knuckle joints are reliable for load bearing applications where some flexibility is needed in the alignment of connected parts. So we're going to switch to the CAD work. So to create a CAD work of knuckle joint, I'm going to use Creo parametric 7.0, and here I'm just open a drawing file which is I have already created with a snap image of a knuckle joint. In this drawing we can able to see the 3D representations and 2D representation of a knuckle joint. In 3D representation we can see all the major components like fork end, eye, knuckle pin, taper pin and collar and all. In 2D representation, the two views which is given in the bottom represents the dimensionals of all the parts and its functions in the knuckle joint. So in this we can able to see all the dimensions are derived from the one dimension which is diameter of the knuckle pin in D. So to generate this CAD model, I'm going to have two assumptions. The first assumption is the D value, which is a diameter of knuckle pin. I'm going to consider it as a 30 mm, and I'm going to use first angle projection to create the CAD models. So these are the major two assumptions which I'm going to carry forward for this CAD model, and rest of all the dimensions will be taken care from this D equal to 30 mm. So we'll start the CAD models. So I'm going to create a new CAD file. In the part level, I'm going to enter a description as fork end and enter. So here we can able to see a Creo CAD file has been created. Now I'm going to click on the extrude. I'm selecting the top plane, moving to switch view. I disable all these items, create a center line and here as well. Now I'm going to create a circle, two circles which is coincidence along to each other, and I'm going to create this particular portion of this fork end. The diameter of the fork end at the edge is considered as the 2D. I'm going to replicate that same. This will be as 2 into D value is 30 as I mentioned, and this will be equals to the D 30 mm. So this will be the first sketch we are going to create in this knuckle joint of fork end. I'll just click OK, and we are going to extrude it in the symmetric condition and switching it to symmetric, and the total extrusion value is will be from this to this will be considered as this height will be as a 0.75d, this height will be as a 1.2 into d, once again 0.75 into d. So 1.5 and 1.2 is gives total 2.7. so this value should be equals to 2.7 into d value is 30 as we have already know. So once we have created this extrude, next I'm going to create the remaining portions. I'm going to create an extrude. I'm selecting the front plane, switching to that view, and now I'm going to create a sketch here. Before going to create sketch, I'll just create a center line on both the axes for the horizontal as well as vertical. So to create this particular portion, I'm going to refer the CAD from this center. I'm going to have a 1.2 into D for this edge and 1.2 D for this center of this portion. So I'm going to create an center line on two edge corners, which is equals to the distance of 1.2 into D, just 36. Consider it as 36. Okay, from this extrude I'm just going to have this kind of a structure, and I'm going to replicate the same for the bottom. I'm selecting all those lines, and I'm going to click on the mirror command, and I'm select this center line. I'll get the same mirror option here. So for me this distance will be as 36. Yeah, it is already there. From this I'm going to create a radius of 1.35d, that even we can make it at the end. This height distance is equals to 1.2 into d, so this distance is equals to 1.2 into d that I have made as one, made that is, and the distance from the center to the end is 4d. I'm going to select this center line to this distance is 4d, 4 into 30, which is 120. Yeah, so the next is I'm going to create a circle from here to here, which will be equals to 1.35 into d, which will be as a 45. Yeah, so I'm getting 40.5. I'm getting this value. Perfect. So I'm going to delete all the unrequired items. This is not required, this is also not required, these are all not required lines, and this too. So in this condition I have created a line. I'll just click OK, and this extrude also I'm going to make it as a symmetric with the extrusion length of 1.2 into d, 1.2 into d. I'm getting an extrude at the edge here. Okay, I'm going to cut this section in the half of the portion, and I'm going to delete all these lines and enter extra lines, and I just click OK. So now once again I'm going to create a whole command here. Even in this command we can able to make only the outer end circle, which is only the dia 60 is enough. Just click OK, and this extrude is getting filed. That is not an issue, we can resolve it. Now I'm going to create a whole command here, which will be on the center of the axis, and for that I'm going to create enable the planes. I'm going to align with the plane in x-axis and y-axis. This distance will be as a 0, and the diameter of the hole will be as 30 mm, which is equals to d, and I'm going to have a length of until the last through all. So the hole will be created until the end. The next I'm going to create a cutout which is in the mid portion. I'm selecting extrude, I'm selecting the mid plane and switching to the view, and here I'm going to create a sketch here. Instead of that I'll create a center line in the horizontal axis and the vertical axis. Now I'm going to select a line, creating a line here, which is the distance is equals to 1.2 into d value is 30, if I'm not wrong. Yeah, it is 1.2 into d into 30, and I'm going to create a circle, and the circle diameter will be is equals to 1.2 into d. How I'm going to define this value is equals to 1.2 into d means the radius which is in the inner is all the diameter value of this radius is actually equals to the size of this eye. The size of the eye has been defined here as a 1.2 into d, so it can be considered as same as for this hole. So from this hole I'm selecting here edge, clipping to the edge, and also I'm mirroring this line with respect to horizontal line, and I'm going to corner this line. I'm going to connect these 2 points, these 2 open points, Now I can delete all the unwanted line items. So I'll get this kind of a feature, and this feature I will make it as a symmetric extrude until some extended value. I'm going to give remove material. So here we can able to see the material of that particular portion has been removed. Next we are going to create a shaft at this end, which is actually equals to the diameter value of d. We can able to see here it is a circular shaft. So I'm going to take a reference from this point to this point. Make it a sketch 2 view. I'm selecting this horizontal axis, and I'm going to select a vertical axis. Instead of that, I can able to select this plane as a references, so that I don't want to have a extra dimensional constraints here. So from this I'm going to create a circle which the diameter is equals to 30, and I click OK. This extension is not yet mentioned in the CAD drawing, but we can have it as our own. I'm going to have a length of 50 mm, which will be as a good number. Next we are going to create a cut in this portion. For that also I'm going to select an extrude, selecting this face, switching to the sketch view. For this I'm going to select these two edge surfaces as a references. This first edge is already been selected, second references I have selected. Now I'm going to create a tangential line which is like this and this. Here I'm going to have both the lines in the equal values, so I'm mentioning it as equal value, and the length I'm going to consider like 5 mm. Now I'm going to give an arc like this. I'm going to delete this tangential, and this radius should be like somewhere here. Value can be as 10, and I'll just click OK. Okay, before getting into click OK, I was supposed to select mirror command for make this particular sketch in all 4 directions. So I'm going to create a horizontal center line and vertical center line. I'm selecting the sketch, click on the mirror command, select the vertical line, it will be replicated on the right hand side. Once again select all the entire sketch, click on the mirror command, select the horizontal line, it will be replicated in the bottom. So now we can able to see the same sketch has been replicated on all 4 corners. I just click OK. I'm going to reverse this direction, and I'm going to give remove material. Yeah, remove material is selected by automatic, and the distance is given as 36 mm. Let me consider as 30 mm will be a very good number. So as of now, here we can able to see a CAD model for the fork-end of the knuckle joint has been generated. In this, if you want to add any radius or fillet to this edge or this edge, you can able to add. I'm going to create a fillet for this edge as well as on this edge, not with a value of 36. I just like to reduce it to 20, which looks somewhat good. Yeah. And also if you want to create any radius at this corners, yes, of course we can able to do 20 on all 4 corners. It is done. And now if you feel that you need a fillet radius at this edges, means here also you can able to give, but the radius will be as a very minimal. I'm going to give just a 0.5 mm radius for this all these corners. So here you can able to see for all these corners I have given a radius of 0.5. So the fork end of a knuckle joint has been created. I'm going to save this model, and I'm going to create apply a different color. I would like to apply green color. It will looks good. Green color for the fork end is done. The next CAD model we are going to create is the eye, which is in the middle portion of the knuckle joint. Eye is a very simple component where we have only one single rod. We can able to create it very easily. I'm going to create a new CAD file, rename it as eye, and click enter. In this particular file, I'm going to have enable the planes. I'm going to select the extrude. I'm selecting the top plane. So I'm going to move to switch view. I'll disable all those planes, add a center line in the vertical direction as well as in the horizontal direction. So now I'm going to create a circle with a diameter of 1.2 into d, which is 36. That's a great. Now I'm going to create another square structure like this, which is this particular dimension is also equals to 1.2 into d, which is a 36. So this comes in the direct value, and the length of this eye rod is also equals to 4 into d. So it is also 4 into d. We no need any, so it will be as a direct, no any issues. And this particular hole I'm going to consider it as for 2d, which is, oops, it is moved to 600. I just need a 60. Having a 60, and this length will be as a 1.2 into d, this will be as a 2 d, and this length will be as a considered as 4 into d, which is 120. Now I'm going to delete all the unrequired items so that the model will be has a closed loop, and I'm going to extrude the distance of 1.2 into d, that is 6 in the symmetric condition, and I'm going to create a hole in center portion. I'm enable the planes, constrain with the planes in the x direction and y direction, so the distance will be considered as 0 on both, and the diameter will be as a 30. Distance I'm making it as a through all. So here we got the eye portion as the same. I'm going to add a radius here and here with a radius value of 20, and I'm going to give a radius at this corners and this corners for the radius value of 0.5. Now I'm going to create a shaft. Oh, sorry, not in this particular portion. I'll just frame this references and sketch. Yeah, sketch view. No, this is not my required face. I'm going to click extrude. I'm selecting this surface and I click on the sketch view. Yeah, I got this. I'm selecting this plane as a references, so I will get the center point. I'll create a center line and this center line. I'm creating a circle for the diameter of d30. Click OK, and I'm extruding it for the length of 50, as what we did it in the fork end of the knuckle joint. Next, we are going to create a cutout for here. Click here and select the edge corner surfaces, this one as well as this one. Click OK. I'm going to create a tangential line to this line and to this line. Both the lines will be on the same distance. I'm giving equal values. The value will be equals to 5 mm, and I'm going to create an arc from here to here like this in the radius of 10. Click OK, and this should be in the reverse direction so that we can remove the materials. I flip the direction, remove material, and the total distance is for 30. Yeah, it's good. So yeah, it's good. Now I just wanted to mirror it for all the portions. Even you can able to mirror in the using the outside tool. I'm going to mirror it in the sketch workbench itself. So I'm going to select this center line and apply on horizontal and vertical. Select this area, click on mirror, select the vertical line, you will get it off. Select this surface, select this lines, click on mirror, select the vertical, you will get it on the right hand side. Select entire thing, select the mirror and click on the horizontal line, you will get on the bottom as well. Now you can click OK, and the distance has been measured, so you have got this cutout here. I'm going to give a different color for this eye portion, which I would like to give a dark gray, and I'm going to save this model. So fork is done, eye is done. Next we are going to create a knuckle pin. Knuckle pin is a center rod where it has a dimensions like 1.5 diameter for this head, and the thickness is 0.5 d. The total length will be like consider as will be as a 0.5, will be as a 0.75, 0.75, 1.5. This will be as a 1.2, 1.5 and 1.2, 2.7, 2.7 plus 0.5, 3.2, 3.2 plus 0.5, 3.7, and here, which is total 4, which is given here. So even in this kind of method, you can able to verify whether the dimensions is matching with the stack up or not. So the total height of the knuckle is equals to 4d. That we are going to create. I'm going to create a CAD model for knuckle pin. Knuckle pin, click OK. For this knuckle pin, I'm going to use a revolve command. Selecting the revolve, select the front plane, switch to section drawing view. I'm giving a center line in the horizontal portion and axis line for the vertical portion. Since we are going to use a revolve command, we need an axis to revolve. So now I'm disable all those things. I'm going to create a sketch without any dimensions. I'm just creating directly, and I will constrain it now. So this diameter will be looks like 1.5 into d. So this will be as 1.5 into d, and this height will be like 0.75 into d, right? Yeah, 0.75, sorry, 0.5 into d, 0.5 into d, and the total height is will be like 4 into d, selecting from here to here. 4 into d is 120, okay, and this bottom is equals to d, 30 mm. So I'm going to close this loop and we are going to click OK. So the pin will get revolved towards that axis. In this we need to add a hole at the bottom for attaching the tapper pin. So to add a hole, I'm selecting the hole, selecting the mid plane. With this help of the mid plane, I'm going to give constraint for as 0, and another constraint I'm going to give from the bottom plane, which will be considered from the height of, from here I'm going to consider as a 0.5d, and the total distance of the collar pin is 0.5d, so I'm considering mid for 0.25, so the total distance will be like 0.75d. So this distance will be like 0.75 into d. So for this height and the depth I'm going to give on the symmetric way to the extended length, and the diameter will be considering as of now I'm considering the diameter of the tapper pin in the one end is 0.25 into d. That will make it as 5 mm as of now, but while I'm designing the tapper pin I will explain how to calculate the tapper ratio. Okay, so I'll just save this model as well, and I'll give a color for it. I'll give a red color, it will be nice. So the next I'm going to create a collar. So to collar the object which is in the bottom of the knuckle joint, here we have a dimensions like 1.5d will be as a diametrical value and 0.5d will be as a thickness value. As the same, we have a diameter in a hole at the mid of the portion. So we are going to create a collar. I'll just rename it as collar, click OK, and I'll enable the planes. For this also I'm going to use a revolve command, revolve command. I'm selecting the front view, going to switch this view. I'm going to give it just a small square kind of a rectangle kind of a shape. I'm going to give a center line and an axis. So based on this axis, the diameter of this internal hole will be equals to d, where the knuckle pin will pass us. The outer diameter will be considered as 1.5 into d, that we are going to give 1.5 into d, sorry, 1.5 into d. Thickness is considered as 0.5 into d, and we'll just click OK, so that a collar will be generated in a revolve command. Next we are going to give a hole, the hole command once again, selecting this plane. I not this plane will be as a first constraint, this plane will be as a second constraint. Yes, so in this first plane I'm going to have a value as 0. In second plane I'm going to have a value of 0.25 into d, which is half of this collar height. And I'm extending the length, I'm making it symmetric, so it will be on both sides, so we can able to see the hole has been generated on both sides. I'll just click OK and disable all the features. A collar has been generated. Going to view, click on the colors. I'm going to give a golden color for this collar. I'll just generate and save this model. The final part is we are going to create a tapper pin. I'm going to create a CAD model for tapper pin, create a file, click enter. In tapper pin we are going to have a CAD structure like a pin which starts with the bigger diameter and ends with a smaller diameter. The smaller diameter dimension they have given as 0.25 into d, and the length they need to be given. In this condition, if you wanted to identify the bigger diameter or smaller diameter, or the length of the tapper pin or the tapper ratio, so the formula to identify the tapper ratio is considered as capital D minus small d divided by length. For example, if the capital D, the bigger diameter, is considered as a 6 and smaller diameter is considered as a 5, and divided by the total length we are considering it as 50 mm, then the value will be like 1 by 50, which will give 0.002 kind of thing. So this is the formula which is used to find the tapper ratio or calculate the tapper ratio. In this condition they have given as 0.25 into d. The value of 0.25 into d is, so the value of 0.25 into d is 7.5 mm. I'm considering the bigger diameter as 7.5 mm and the smaller diameter as 5 mm, and we are going to generate a CAD model for it. For this tapper pin also, I'm going to select a revolve command. I'm clicking on the front plane. I'm moving to the sketch view, disable all these planes. I'm going to select a center line for the vertical condition and the axis line for the horizontal condition. I'm going to create a tapper pin with 7.5 mm in one condition and 5 mm in another condition. I just make coincidence with this. This diameter should be considered as 5, this diameter should consider as 7.5, this length will be considered as 50. So this is the sectional view of the tapper pin, and here's the CAD model of it. So I'm going to create a color for this like in a steel. I'm going to apply a color, steel color, for this particular tapper pin, which looks even more good. Next I will save this model and this. So I'll just showcase one by one. This is a fork end which we have created the initial, then this is the eye rod, then the next is knuckle pin, and the fourth component is collar, and the fifth component is tapper pin. So these are the 5 components which is involved in a knuckle joint. As you know about how to create a CAD models for the knuckle joints and its parts, now we are going to create an assembly. In this assembly, I'm going to create 2 different kind of assemblies. One is for the rigid connections and one is for the flexible connections. First I will showcase how to create a rigid connections. Let's see the animation. Let's see the assembly. So I'm going to click a new command. I'm selecting an assembly file. I'm going to give name as knuckle joint. Enter. Okay, I just placed as knuckle joint. That's fine. I'm going to enable all the planes. First I'm going to assemble the fork end in the default condition. In this current constraint, it is an automatic. In that I'm going to make as default. Default is, it is just direct affix with a 0, 0, 0. Next I'm going to assemble the eye portion. In this eye portion I'm going to give constraint between this hole to hole will be as a coincidence, and the surface from here, this surface and this surface, to be as a coincidence. Oh sorry. Next constraint, I'm going to give this surface to this surface as a coincidence. And the third constraint, because we have 1 degree of freedom in free, to obtain this I'm going to select this face to this face in a parallel condition. This gets college. Just you can click on the flip button, it will comes in the opposite direction. So this is assemble of knuckle joint in fork end and eye. Next we are going to assemble the knuckle pin. I'm selecting the knuckle pin. This knuckle pin diameter and this whole diameter will be gets coincidence. The surface of this and this will be gets coincidence. In this, the pin will can be rotated. It's not an issue. It can be as a flexible. Here we can able to see the hole has been gone very inside. That we will be take care. Next we will assemble the collar. I'm selecting this. In collar I'm going to select this particular portion and this particular portion to be as a coincidence, and I'm going to give hole and hole to be as a coincidence. In this we can able to see it is getting oriented, but we can able to manage this. I will show how to manufacture this. Next we are going to give a tapper pin. In tapper pin also I'm going to select this surface to the whole surface in a coincidence of the axis, and I'm going to select this face to this face, not in the tangent. Okay, it will allow only in the tangent because it is a circular face and that is in a structural straight face. So that I'm going to enable the plane. I'm selecting this plane to this plane for the particular distance of 25 mm. I hope it will be as a perfect match. So now we are just going to modify a small connection in this knuckle pin hole, since it has been very inside of that. So to identify that, I'm going to select the hidden line and I'm going to identify how much distance is required for that. So the distance from this surface to for that I'll just make it as into this itself. I'll hide the eye portion, I'll hide the collar, collar is needed, tapper pin, a knuckle pin, and I'm going to measure the distance. The amount of distance it is getting merged is 6 mm. So now we are going to reduce this hole height for 6 mm. I'll just select this hole, click on the D1, I'll get the dimensions. So this height is 22.5. I'm going to minus 6 mm in this, so it will become as 16.5. I'll just regenerate the model. Automatically all the parts will get regenerated successfully, so no any extra burden will be there, won't be there. So you can able to find how the knuckle joint connection has been made. So this is the rigid connection assembly of a knuckle joint, where we are going to have a fork end, eye, knuckle pin, collar and tapper pin. So these are the 5 components of the knuckle joint. Here we can able to find the assembly. Next I'm going to explain how we are going to create an assembly with an animation in a flexible connections. So let's see how to create an animation. So to create an animation, I'm going to create another one assembly part. Here I'm going to give name as knuckle joint animation, and I just click OK. In this, we are not supposed to give any rigid connections between the parts. Everything should be as a flexible. First, I'm going to create an axis in this way, because we even for the first point, if we keep it as a default or a rigid, that particular part will be get fixed to the axis systems. It should not be in a fix, it should be in a flexible to make some animations. So I'm going to click on assemble. I'm selecting the fork end. For fork end, I'm going to select, instead of user defined, I'm going to select the pin. This is a pin constraint where we are going to pin this axis to this axis, and the planes from this to this will be as a coincidence. So these are the only 2 constraints which we are going to give. So 1 degree of freedom will be kept it as free for this rotation. Okay, so I'll just click OK here. The second component I'm going to assemble is eye. For eye also, I'm going to select the pin connection. For the pin connection, I'm selecting this axis to this axis, and the translation movement will be connected between this. Okay, before that I just wanted to add this. I'm going to select the eye. I'll rotate this. Now I'm going to create a pin connection. I'll just select this axis to this axis, and the whole constraint will be given from here to here. It won't be as work. Okay, I'm going to select this plane to this plane will be as a coincidence. Okay, so here also we can able to see it has been as a flexible one. I'll just make one more correction. I will make sure to have an axis line connection between I to fork end, not with AA1. So I'm going to remove this AA1, and instead of that I'm going to give connection with this axis which is all available in the fork. Okay, so we have assembled the eye connection also. In this condition itself, I would like to have a content. Okay, I will make a knuckle pin. For knuckle pin, we don't want to have any rotational movement in independent way. It just wanted to fix with the components. So here we are not going to select any rigid connections or slot connections. We are using only pin. I will make it as axis to this axis, and this will be considered as this surface will be placed to this particular surface, and we are going to give constraint. The fourth component we are going to assemble is collar. Collar also we are going to give as same as the pin connection. Since we are going to run an animation, we should not follow any rigid connections. So for collar also I'm going to select axis to this axis to be as a sorry, I just need to select a pin connection. I just missed it. I'll select, sorry, not as a knuckle pin. I'm selecting a collar. In collar also I'm going to select the pin connection. For pin connection I'm selecting this axis to be constrained with this axis, and the surface to be contacted with this particular surface. Okay, I just selected this one. I'll just try to flip this. It is okay, it won't be active. Okay, the reason is I have given the connection to the knuckle pin. Instead of knuckle pin, I just wanted to give connection to the collar. Sorry, not the collar, not for the fork end. So once again, I'm removing this. I'm going to click on this fork end, yeah, and I'm going to select the surface to fork end surface, and I'll flip this direction, yeah. So the collar is also fixed. The next we are going to have a tapper pin. In tapper pin also I'm going to follow the constraint of collar. So I'm selecting this axis to this axis will be as a distance. Okay, sorry, I just need to, I'll just click cancel. No, I'll select the pin connection. For pin connection I'm selecting this axis to this axis, and I'm selecting a plane to this collar plane, where I will have a distance of 25 mm or 23 mm, like that. So 25 mm I'm placing. Next I'm going to verify for the IN ones, because I was about to give this planes. I'll just remove this, and I'll remove this as well, and I'm going to give pin connection along with this fork end itself. So I'll select this fork end, and translation will be like this plane to this plane. It matches perfectly. Let me verify in the top view. So here we have completed the flexible assembly for the knuckle joint. Next we are going to see how we are going to create an animation for this. So to create an animation, I'm just clicking on this applications. In applications, I'm going to select the mechanism. In mechanism, I'm going to select the mechanical answer. Before, I'm going to assign a servo motor for this axis. Select the servo motor, select the axis to which you want to connect the servo motor, and click on the profile details. Switch this angular position to angular velocity, and make this angular velocity degree of freedom, degree of per second will be as 25 degrees per second, and click OK. So the motor will be assigned here. Next you can go for the mechanical analysis. Before that, you make it into a standard deviation, and you can enter the start time and end time. I'm going to enter end time as 50, and I'm going to click on run. So here you can able to see an animation how a knuckle joint will be operates. The knuckle joints is keep on rotating, so it will be transfer the power from one end to another in a very flexible and relative to the rotation concept. I'll show it once again with a end time as 100. I'll click on the run command. I'll click on S. Here in the bottom you can able to see the bar where the level will be moves, how much time it has been run, how much time it is there. But one thing, when it is moving in the animation video, you can't able to make any changes, any clicks on the Creo. You need to wait until it completes. So this is how the animation looks like, and this is how the knuckle joint will be works in the application level. So just close this, and if you wanted to save this applications, you can save in the motor condition, and anytime you can run it and you can see. I'm going to save this assembly level also. So I hope you guys understand how to create a CAD model for the knuckle joints from the part level, and on how to assemble a knuckle joint in rigid connections, and also how to assemble a knuckle joint in flexible connections along with the animations. So in case if you have any doubts, you can post in the comments. In this we can able to explore more. So this is the concept how we are going to create a CAD model for the knuckle joint. So guys, thank you for watching this video. Thank you. Bye bye.